Can we eliminate darkness at night with an orbital reflector? How long do the Voyagers have left? Why didn't James Webb inspect some of the potential ocean worlds? And in Q&A Plus, could we see the Great Attractor unobscured? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Giga Sigma. Thoughts on putting a reflector in orbit to eliminate darkness at night? So I've done an interview with scientists behind that idea, and we talked about it in the episode. So it was about a year and a half ago, I think. And the idea was that you could have a reflector that would give a little bit more sunlight to northern regions, places where light in the wintertime is at a premium. Cities, things like that to the north. And it is theoretically possible. It's going to be incremental. In other words, that, you would have to make a gigantic reflector that would be very expensive to launch. And the benefits that you get is like a little bit more light outside during twilight, during night. They were making the argument that there's a few sort of niche reasons why you would do this. But, that does not create an overwhelming financial incentive to do a thing like that. And there are plenty of potential downsides. Animals are confused by light being there in the wrong places. Think about how moths are always sort of going after your lights. Our own sort of day-night cycles get messed up. There are potential consequences, and then you're essentially adding to the net energy budget of the planet Earth at a time when we're already concerned about adding to the net energy budget of planet Earth, right? Light rays that should have missed the Earth are being redirected to hit the Earth. And so you're pumping more energy into planet Earth. Not very much, but it's not zero. So, until somebody makes like a really compelling reason why you're going to want to redirect this light to the Earth, I think most people, most scientists, most policymakers are going to go, nah, right? I think people dramatically underestimate how expensive it is to put things into space. There's all this talk right now of putting data centers in space. And, people think like, wouldn't it be cool if we put data centers on the moon, right? If you could teleport data centers to the moon or teleport data centers into space, then there would be like a bunch of challenges, like you can't fix them, you can't repair them. You have to have solar panels that are pulling in energy. You've got to have appropriate amounts of waste heat that is being radiated back out into space. The farther away you have it from the Earth, the slower the transmission times. You're going to have to sort of do heavy processing on these things, but not be able to transmit a lot of data to and from your data satellites. But that's if you teleport them, right? Like it would be like a marginal business case if you teleported them, but you don't teleport them. You have to put them on a giant rocket, and you have to spend tens of millions, if not hundreds of millions of dollars to put these things into space. $1 billion to put these things on the moon. Suddenly your cost incentives go out of whack. And so always you have to consider, does it make sense to do this kind of stuff when you take into account the full process, as opposed to just, turn on a light outside, as opposed to dig a hole in the ground and grab some gold, as opposed to set out a bunch of solar panels to harvest electricity. So it will always be competing with just doing stuff down here on Earth. Biggles Tintin. How long will Voyager 2's power last? So the Voyagers were launched in 1977. And have been operating continuously all of this time, right? They're almost at their 50-year mark, but they are powered by an RTG, a radioisotope thermoelectric generator, which is a chunk of decaying plutonium that gives off heat. Then they have a thermocouple that is attached to the RTG that turns that heat into electricity. And because plutonium is a radioactive element, it has a half-life, it is producing less and less of this heat over time, which means that there's less and less electricity that's available to the spacecraft to be able to run its operations. And over time, over the decades, NASA has shut down each one of the instruments on board the spacecraft to make use of the remaining electricity. Now, a lot of the instruments are no longer necessary. You're not going to need to have its camera system because it can't take pictures of anything. Now it's out there in deep space. The real value now, because they're so far away from the sun, is that they're sort of detecting the presence of interstellar material. They tracked their movement through the outer layers of the atmosphere, through the heliopause, heliosphere, helioshock, heliosheath, and into interstellar space. And they sort of experienced as, various solar activity and was decreasing and increasing the size of the heliosphere. And they've been able to give this really interesting information. So there's a few scientific instruments still on board, as well as their communication systems, so that they can still send all of these data back home to NASA. But the power continues to decline. And how long the power is going to last is still an unknown. We're probably in the last 10 years of life for the Voyagers, but exactly when NASA is going to make that call and shut off the last instruments, we still don't know. But they're still sort of extracting every little piece of science that they can from them until they have no other choice. That, there's only enough power to either operate a science instrument or send data home. At that point, you might as well turn the thing off and focus those resources on other things. Part of the problem is that NASA is constrained by its ability to communicate with the deep space spacecraft. It has this thing called the Deep Space Network. These are sort of giant radio dishes around the world that it uses to communicate with the different spacecraft around the solar system. And you can go to the Deep Space Network page and you can see which spacecraft NASA is communicating with right now. And so if the spacecraft can no longer deliver usable science, they will free up slots for the Deep Space Network to communicate with other spacecraft. So, they're not going to leave them around longer than they need to. We're probably in the last 10 years or so. But I think I said that in a video 10 years ago. So who knows? Asma RL, why do we call Venus and Mars Goldilocks zone planets when they're not inhabitable? Doesn't this mean that we're looking in the wrong zone around other stars for Earth-like inhabitable planets? So the habitable zone, really the only rule for the habitable zone is that in that region, liquid water can exist on the surface of an exoplanet. Full stop. That's it. So you do the math and you say, with the thickest possible atmosphere, with the right conditions, can you get liquid water to form on this planet? If it's too close to the star, then no amount of good atmosphere, perfect conditions is going to make water be able to form. It's going to boil away. It's just going to be too hot. And then on the flip side, you say, is there no amount of perfect atmosphere that could get us to this place where you could have liquid water on the surface of this planet? It's just going to freeze. And in between that zone is the habitable zone. There is theoretically water on the surface of those worlds. Now, practically, as we see here in the solar system, it isn't always the case that you look at Venus. Venus is this sort of runaway greenhouse effect. It's too hot. It has a thick atmosphere of carbon dioxide. But you could tweak the atmosphere of Venus in ways that would get it to be a planet that is habitable, that is not too hot, that there's liquid water on its surface. It might be, steamy. It's going to run at a higher average temperature than the Earth does, but it is theoretically possible. And then the same thing with Mars. We know that Mars had water on its surface in the past. It doesn't have it today. The atmosphere is too thin. But if you came along and you thicken the atmosphere and put in the right constituents of it, you could tweak the planet to get to a place where there is liquid water on the surface of Mars. It could be as habitable as the Earth. Well, not quite as habitable because it gets less energy from the sun and it lacks a planet-wide magnetosphere, but it could have a planet-wide magnetosphere, if it was a little bit larger. My point is that really the habitable zone is really this very blunt hammer to just come with this first pass, right? And then the second pass, theoretically, when we have the tools, when we have the chops, is for us to examine the actual planets in that zone to find out if they specifically do or do not have the various indicators that we're going to be looking at for potential for life, that it does have water on its surface. How do you know if a planet has water on its surface? That is a really complicated and very tricky observation to make. It is beyond the capability, probably, of our current generation of telescopes. But what we can do is examine the atmospheres of planets that are in those zones. Actually, we can't even do that. We can examine the atmospheres of planets that are in the habitable zone around red dwarf stars, maybe. That's where we are right now, technologically speaking. And then the next generation of telescopes will hopefully allow us to be able to examine the atmospheres around planets orbiting not only red dwarf stars, but maybe around stars like our sun. And then people have come up with other ideas about how you might be able to detect the presence of a liquid ocean on the surface of a world, either through the chemistry in the atmosphere and the interactions between the water and the atmosphere, or maybe you're looking at the reflectivity of the planet, or maybe you're looking at a moon and the planet and how the light is bouncing off the planet, off the moon, and you're able to observe. Like, it's all going to be very difficult, but you need somewhere to start. And so the habitable zone is just this, like, it's possible in that zone. Now, is it there? That's future science to try and figure out. It's time to shout out our new patrons at the $5 level and above. Patricia L., Rotten Dog, Wang Adam, Julia Mays, Ed Storm, John M. Lovelace, Nordspace, Hulavu, Matthew Labato, and Che Weaver. Join our community at patreon.com/universe today. Everything compute. Any idea why James Webb has not observed the spectra of planets like Kepler-22b, which is an ocean world? So we don't know if Kepler-22b is an ocean world. There was a science study that came out that looked at the chemicals in the atmosphere of Kepler-22b and proposed that it might be an ocean world. But other people have suggested that there are plenty of other chemistries that could explain the signals, because you're not seeing the water glinting off the surface of Kepler-22b. You are seeing spectra of various chemicals that are present in the atmosphere of the world. You're seeing methane, you're seeing carbon dioxide, and some other chemicals. I think a hint of sulfur dioxide, but people argue about whether or not that's present. And sort of this is following this idea of Haitian world, that you can have planets which would be considered not in the habitable zone, but if they have a thick hydrogen atmosphere envelope and they have a very deep ocean of water, it could be liquid water on the surface of the planet, and it sort of violates the habitable zone and actually allows for things to be inside or outside of the habitable zone. There's even been ideas that these Haitian worlds, if they exist, could even be habitable around, say, a rogue planet, just purely through the tidal interactions of the planet. So that's one theory, but it is not a theory that is held by all of the exoplanetary community. There are plenty of others who are skeptical about this idea of Haitian worlds at all, that, if you have a planet that has a lot of water on it, it has a mantle. The mantle and the water are going to interact with each other. The water is going to be drawn into the mantle of the planet to a certain degree. The hydrogen is very reactive. You're not going to necessarily get this planet forming in this way. Another perfectly reasonable way to explain what you're seeing is a magma world. That if you have a planet that is covered in magma and the magma is putting out various volcanic gases into the atmosphere, that the chemical signature, the resolution that we've got from James Webb explains the data, and many argue better. And so we're in this world where the tools are not good enough to know whether that planet is covered by a thick ocean of liquid water or a thick, molten surface pumping out volcanic gases. One sounds more habitable than the other, and we don't know which one it is. So we have gotten plenty of spectra on certain planets and learned a lot. Mostly the planets that are being observed that we've been able to get the spectra are already uninhabitable. Right? You're looking at giant planets. You're looking at things where you're detecting the presence of iron in the atmosphere, right? It's like, it's so hot. Really the dream is to find planets that are in the habitable zone around these red dwarf stars. And this has been a really elusive measurement that people have been trying to make. There's this idea of stellar contamination, that the star is having slight variations. And of course, when you're trying to measure the changes in brightness and the chemical characteristics of a planet as it's passing in front of the star, if the star is up to nonsense, that doesn't help your observations of the planet. And so we're in this time where astronomers are recalibrating and developing new data methodologies to try to be able to tease out what is planet and what is star. And we're not there yet. Or at least we're not there yet with the short amounts of time that James Webb has been able to assign to these different kinds of observations. It's going to take longer. And, because time on James Webb is so precious, nobody has been able to get enough time. I mean, I think the observations of the TRAPPIST-1E, I think they had 3 transits that they were able to observe. I forget the exact number, but a paper came out that said, okay, we probably need 15 to be able to really get to pin down whether or not there's an atmosphere on this world that is relatively close, orbiting within the habitable zone of a red dwarf star. This is the kind of planet that if we can find an atmosphere around it, if we can detect the presence of water vapor in the atmosphere, that tells us that maybe there is an ocean there. But so far, none of those observations have been successful yet. Right? Like we're at this time when nobody has detected the presence of an Earth-sized world orbiting around a red dwarf star with an atmosphere within the habitable zone, not to mention Earth-like world, Sun-like star. So it's still early days for this whole process. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, could we see the Great Attractor unobscured? And I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who put your questions into the YouTube comments, everybody who joined me for the live show. We were off this week because of the holiday, but we are back next week. So it'll be Monday, 5 p.m. Pacific time, back with another live question show, 2 hours of your questions, my answers, and then we will edit a lot of that down into the show that you see today. I'm going to respond to a comment that was made about the success of Artemis versus SpaceX. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Barely Griffin, Brian Bode, Caradon, Chuck Hawkins, Commander Bailock, Dark Finger, David Gilton and David Mads, Evan.Pro, James Clark, Janice Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Sitz, Michael Purcell, Nordspace, OneStepAnalyst.org. Please follow my nephew at VBrick6994, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Falamonli, Team 49, Telescopes Canada, Vlad Chiplin, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I got this comment from Raz C. I wonder if everyone at SpaceX was shamed by the casual way NASA showed the space industry how to be uber professional and how to get the job done. I mean, for starters, I think it's really important to separate the folks who work at SpaceX with their leader. They're, the whole team of engineers who have been doing some really incredible things. When you think about what happens with the Falcon 9, that, the booster stage lands at sea and then they bring it back in. When you watch the incredible precision of the Falcon Heavy, it is hard not to be completely awe-inspired by what's going on there. Not to mention the ongoing and continuous success of the Crew Dragon. You've got this spacecraft that has sent many crew to the International Space Station and providing, services for tourists. And so that is, again, sort of demonstrations of SpaceX's capability. And I understand that instinct that watching the launch of the Artemis 2 with the Space Launch System was absolutely incredible. And it transported me back, mentally to a younger age of enthusiasm and excitement. To see humans heading off to the moon again was amazing. There were a couple of minor problems, problem with the toilet, but really it was a real flawless execution. But there were delays. This wasn't the time it was supposed to launch. There was problems that were so big that they actually had to roll it back to the vehicle assembly building. And the amount of time that this mission has been in the works. SpaceX pretty much went from nothing to going through the entire Falcon series and then starting in on the Starship series and getting to where they are today in the amount of time that it took for the development of the Space Launch System. And there have been many delays, sometimes delays at a year or more. And we're at this point now, there's going to be one more launch of the Space Launch System where they're going to be testing stuff out in low Earth orbit. And then the SpaceX solution has to come together with the Space Launch System to carry out Artemis 4. And so everyone's going to have to work together. And I think that there are always these two camps in space exploration and kind of in engineering in general. There's the tech move fast, break things approach, which has demonstrated that it gives you technologies quickly. It sort of overthrows bureaucracy and often will make things happen. And then there's something to be said for the kind of the tried and true, measure twice, cut once, slow and steady wins the race, deliberative methodology of what you saw with the Space Launch System. But then you have to look at the budgets. The sort of entire development budget for Starship is less than the development budget for the Space Launch System. And that a Space Launch System costs like over $4 billion to launch. And theoretically, if SpaceX can pull this off, they'll be able to make their launch costs be in the tens of millions for Starship. You can launch many more super heavy lift rockets than the Space Launch System. And so I think, my bottom line is that right now we are in this sort of uncertain state where we don't know how this is going to turn out. Is this going to turn out incredible for SpaceX? We don't know. Is it going to be a disaster? We don't know. Is the Space Launch System going to continue on and they're going to start continuing to invest in it at $4 billion a launch, but that's going to bring humans back to the moon? We don't know. Are they going to cancel it? We don't know. And so right now, I think we just need to be enthusiastic for all of the organizations that are trying to make space exploration happen. I think we can all agree that we want to see human beings back on the moon. That will be amazing. And that the exact right way that it's going to happen, there's going to be winners, there's going to be losers, and we won't know what worked until all of these ideas were tried out. All right, we'll see you next time.